Hello everyone, welcome to Newton's TV. Today we are going to talk about dosage calculation. So this is part one of the dosage calculation, and in this video I'm going to take you through some basic mathematics review. The reason why I'm trying to do this is sometimes people understand the question that they are working on, but how to go about it is very difficult for them. I'm talking about the mathematical aspect of the question. So I decided to start with this one before we go into the main concept of dosage calculation. So in this particular video, we'll talk about fractions, decimals, percentages, and ratio and proportion. Then in our subsequent videos, we'll go into the main dosage calculation concept. So let's start with fraction. So we know that fraction is a part of a whole. So a fraction has two parts. We have the top number called the numerator and the bottom number called the denominator, right? So there are different types of fractions. We have the proper fraction and we also have improper fraction. We have complex fraction, and we have mixed fraction. So I want to take you through one by one, or each of these fractions that we have. So with the proper fraction, the numerator is less than the denominator, and the fraction has a value of less than 1. So examples the half that we have right here, right? And we also have improper fraction where the numerator is larger than the or equal to the denominator, and it has a value of 1 or greater than 1. Example is 6/5, right? Now, one thing about improper fraction is that whenever you get improper fraction as an answer, you don't have to leave as improper fraction. If you leave it as that, like 6/5, and you leave it as that, that is an improper fraction, and the person that is marking your paper can mark you wrong based on whatever the person think of, right? So when you get an improper fraction, one thing that we need to do is to reduce it to the lowest term by dividing the numerator by the denominator, right? So to do that, we have to get a number that when we multiply, we get something closer to the numerator or the numerator. So what I'm trying to say is that we have to get a number that when we multiply the denominator by it, that number. So let's say the number is x. So we are looking for a number x that when we multiply by the denominator, we get a number the number 6 or closer to 6. So what number are we looking for, right? So let's say, what number can we multiply by 5 to get 6, which is 1? So we write our 1 there. So the 1 will be a whole number, right? So multiplying 5 by 1, we get 5. So how many numbers, or what number can we add it to 5 to get 6? Is 1. So we want 1. So the answer that we are going to get here is going to be one whole number, 1/5, right? So simply, when we multiply 1 times 5, we get 5 plus 1, which is 6, so which is equal to 6/5. That's what we are talking about. Let's take another example right here. So let's say we have 7 7/5, right? How do we reduce this to proper fraction, right? So we want a number which is x that when we multiply by 5, we get 7 or closer to 7. Which number is that? So x times, or 5 times x, right? So 5 times 1 will give us 5, right? Which is closer to 7. Now we want exactly 7. So what number is added to 5 to make it 7? Which is plus 2, right? So the whole number is 1, then 2 on top over 5. So 5 times 1 is 5 plus 2 is 7. So 7/5. Simple, right? That is improper fraction. So whenever you get an improper fraction, the best thing to do is to reduce the improper fraction to proper fraction, right, to the lowest term. That's what we did right here. Now let's go to complex fraction. Now complex fraction is when the numerator or the denominator may be either a fraction or a whole number. So we can get something like 1/2, as is written here, 1/2 on 2, right? Or 1 on 2 on 1 on 3 on 4, as written right here. So that is complex fraction. Now in this type of fraction, now let's take the 1 on 2 on 2, right, and try to write it to make it a proper fraction, right? So we have 1 on 2 on 2, which is simply written as 1 on 2 divided by a whole number 2, right? Now whenever you have 1 on 2 divided by a 2, this 2 is typically on 1, right? So any number on 1 is equal to the number itself, right? So in this form, you can write this one as 1 on 2 divided by 2 on 1, right? So we want to make sure we have a fraction, right? We have a single fraction, not a kind of a double fraction like this. So what are we supposed to do? So whenever you have a number like x on y divided by z on w, right, what we are supposed to do is to maintain this first fraction here, which is x on y. Then we change the sign, which is the division sign, to multiplication sign. Then we move the w in the numerator. So the right here, the w is the denominator and the z is numerator. So we are going to swipe each of the w and the z so to different positions. So what we are going to do here is to bring the z to be a denominator and the w to be a numerator. So we will have here w on z. Then we can multiply and get a single fraction. So now let's go into the typical number here. So we maintain the 1 on 2, then we change the division sign to multiplication sign, then we bring the 1 on top, then we bring the 2 down to be the denominator. Then we can multiply and get 1 on 4 to be a proper fraction. So whenever you get a question like that, you can use this to do that, right? Now let's go to a mixed fraction, right? So the mixed fraction, there's a whole number and there's a fraction combined with a value greater than 1. Example is 3 on 2, right? This is a mixed fraction. This is a mixed fraction. Now remember when we talk about improper fraction, whereby we can do an improper fraction, right, to become a whole number and a proper fraction like 1 on 2. Now this is called a mixed fraction, right? So we can change a mixed fraction into an improper fraction. We can change improper fraction to a mixed fraction. So that's what we are going to talk about here, right? So a mixed fraction, when we have this one, right, so you can see that we have 3 whole number 1 on 2, right? Now when they did it, they got an improper fraction. Now we can change this improper fraction into a mixed fraction, whereby we look for a number. When we multiply by the denominator, we get something like 7 or closer to 7, which is 3, right? So when we multiply 2 times 3, we get 6, right? We get 6. Now 6 is closer to 7. Now we are looking for something like 7. We are looking for 7. So what can we add to 6 to make 7? That is plus 1, right? So we have a whole number of 3, then 1 on 2, right, which is we have here. That is a mixed fraction that we are talking about here. Now remember that unless asked to give an answer as an improper fraction, never leave it as such, right? That's why we talk about it. Whenever you get an improper fraction, never leave it, because you are gonna get it wrong. Always put it as a mixed fraction. Always put it in the mixed fraction form, because in the mixed fraction we get a whole number and a proper fraction, right? Now we have some problems right here. You can pause the video and try to use whatever I've explained here to do this practice problem right here. Now let's go to our next thing here. So in this part of the video, we are going to talk about addition fractions, right? So in addition fractions, how we are going to look at how to add fractions. So to add fractions with the same denominator, we add the numerator and place the sum over the denominator and reduce it to the lowest term. So what they are trying to talk about here is that whenever you have like let's represent a number like z and x plus z and x. So this is y over x, then z over x. Now we can see that the denominator are the same, x and x. Now in this type of additional fraction, we don't do anything to the denominator, we just leave it as such. The only thing that we have to look at is the numerators. So we just add the numerators and bring one of the denominator, which is the same thing, right? So we add the numerator, which is y plus z on x, right? So let's look at some numbers like 4 on 5 plus maybe 3 on 5, right? So in this kind of form, we have the denominator to be the same, like 5 and 5. So we leave the 5 to be the same, then we just add the numerators, which is 3 plus 4, which is 7 on 5, right? Now you can see that in this form we have gotten improper fraction, so we have to leave it in proper fraction or mixed fraction. So in this form, when we try to reduce it, we have to look for a number. When we multiply by 5, we get something like 7 or closer to 7. So which number is that? Which is 1. So 1 times 5 is 5. So what number can we add it to 5 to get 7, which is 2? So it will be 2 on 5, right? So this will be your answer, right? Very simple. Now let's go to subtraction of, okay, before I go to the subtracting fractions, what about if you don't have the same denominator, right? So let's say you have maybe y on x plus z on w, right? So in this form right here, we have different denominators. So what we are going to look for is look for the lowest common factor, right? So we have to look for the multiples of x, right? And we have to look for the multiples of w to the where we get the lowest common factor, right? So let's look at some numbers right here. So let's say we have 3 on 5 and plus 2 on 4, right? Now let's look at some multiples of 5. So 5, 10, 15, 20, then 25. Now let's look at multiples of 4. We have 4, 8, 12, 16, 20, 24. Now the lowest common factor that we found in this multiple here is 20, 20. So therefore the LCM here is going to be 20, right? So that will be 3 on 5 plus 2 on 4, which will be 20, right? So that's the lowest common factor right here. So how much can 5 go into 20? That is 4, right? That is 4. So you multiply the 4 by the 3. So 4 times 3, then plus 4 will go into 20 how many times? That is 5. So 5 times 2, right? So you just multiply how many times that denominator can go into the lowest common factor, then you add them, right? So 4 times 3 is 12 plus 5 times 2 is 10 over 20. So when we add it, we get like that will be 22 over 20, which we can reduce it to the lowest term. So 11 will go 2 will go here, 11, 2 will go here, 10, right? So this is an improper fraction, so we have to reduce it to the lowest common term right here. So 10 can go, what number can we multiply by 10 to get 11 or closer to 11, which is 1? So 1. So 10 plus what number will give you 11, which is 1. So 1 on 10, right? So this will be your answer. Very simple. The same thing applies to subtracting of fractions, subtracting fractions, right? Now when you have the same denominator, you just subtract the numerators and you get your answer. When you have different denominators, you use the same thing, but you just subtract it after multiplication, right? Now straightforward, let's just go to multiplying fractions. It's very simple. It's very, very simple. So whenever you are multiplying fractions, we don't need to go and look for any lowest common factor, right? So like what they did here, like 3 on 4 times 2 on 5. You just multiply the numerator and you multiply the denominator, then you get your answer, which is 6 on 12. Then you reduce it to the lowest term, which is 1 on 2, right? Very simple. Now division, dividing fraction 2 is very simple as well, right? As I said, whenever you have, like, let's say you have 3 on 4 divided by 2 on 5, right? You just maintain the first fraction, which is 3 on 4. Then you change the sign to multiplication. Then you swipe the denominator to be a numerator, then numerator to be a denominator, right? So we have 5 on 2. Then you just multiply, then you get 15 on 8, right? So in this kind of form, you can also do it to get your proper or your mixed fraction, right? Very simple. So we have some problems here. You can pause the video and trying to do this problem, and if you have any question, do not forget to put it under the comment section and I'll answer your question. Now let's go to the next one. So the next one that we have here, so with this one, let's talk about decimal. So decimal play a crucial role in dosage calculation. So if you don't know how to place your decimal point, it's going to affect you when you are calculating your dosage calculation. So what is decimal? So decimal is a fraction that has a denominator that is a multiple of 10. So the decimal point indicates a place value. So the important thing that you need to take note of is when there's no whole number before a decimal, it is important to place the 0 to the left of the decimal point to emphasize that the number has a value of less than 1. So the Joint Commission, like for example, when you have 0.75, right? You have to put the 0.75 in mostly cases, like in American community, you can see them writing like 0.75, which is okay, depends, but always put the 0.75 there to make sure, right? And whenever you see whenever you're writing decimal, unnecessary zeros should not be placed at the end of the number to avoid misinterpretation of the value or overlooking of the decimal point. For example, whenever you are having 1, you can just put the 1. You don't need to put 1.0. If you don't take care and the 1 is the point here, or the decimal point here is taken off, it can be 10. So you just leave your number as 1 as a whole number, 2, 3. You don't need to put like 3.0, 2.0. It's not needed, okay? Right. Now, dividing decimal numbers, right? Dividing decimal numbers is very, very, very crucial here. Now, changing the dividing number to a whole number by moving the decimal point to the right. Changing the number being divided by moving it to the decimal point is the same of place to the right, right? Then you divide as usual, right? So let's say we are dividing like 0.5 divided by 0.25. What can we do? Now, to me, what I'm gonna do is to just move here, right? When I move here, that will be so that will be 5 times 10 exponent negative 1 divided by 25 times, so 1, 2, right? Now in this form means we have 5 on 10 divided by 25 on 100, right? Now what I'm trying to do here is I'm just making sure any number, right, any whole number exponent negative, right, comes down to be 1 on 10, right? So whenever you have like x exponent negative x, 1 on x, y exponent negative is 1 on y, right? That's what I'm trying to do here. So if you have 10 exponent negative 2, so that will be 1 on 10 exponent 2, right, which is 10 squared, which is 100. So 1 on 100. That's what I try to do here, right? So if I have 5 on 10, 25 on 100, I can reduce it to lowest fraction, which will be 1 on 2 divided by 1 on 4, right? So as I said earlier on, I said when you have something like this, you can maintain this, then you just swipe each of this one. So you have 1 on 2 times 4 on 1, then you multiply, then you get your 4 on 2. Now 2 will go into 4 2 times, so you have your answer to be 2. So 0.5 divided by 2.5 will give you 2. Very simple, will give you 2, right? Will make sense when we start our dosage calculation. Will make sense. You can also input that into your calculator and see the answer that it will give you 2. Very, very simple as that, right? Now let's also go into another concept here. So another concept here is we are going to talk about rounding decimals. So rounding decimals is also very necessary. I mean, that's the most important thing in dosage calculation that we talk about. They can tell you to round your answer to one place, the 10th place, the 11th, the 100th, the thousands, and all that. All right. Now, so rounding your number, right? So for me, I'm not gonna look at all this rounding of things here. Now let's look at some examples right here. So that, right? So this problem right here is that we are gonna use the answers in page whatever. We are gonna record your answer using 1 decimal place, right? 1 decimal place. So let's look at 0.75. So in this 1 decimal place, right? So this is 1 decimal place means we are going to look at this part. Now, whenever is 5 or more, we run it, right? It means that we take 1 from here and add it to this the number here, right? To make it 8. If you get it very well, right? If it is 4 or less, let's say 0.74, we just leave the answer to be 0.7, if you get it. So here, if you are running 0.75 to 1 decimal place, we are just going to leave the answer to 0.8, right? Because we just take 1 from here because it's 5 or more, right? Now let's take an example of 2. So the 2, so here is 0.8, and here you can see 0.23, right? It's less than 4, so we just maintain the 2, so it'll be 0.2, right? Then here we have 0.98, right? When we take it to here, we get 10, so we get 1.0, which is 1. Just leave it as 1, right? So here we have 0.36. We just run it, then we take what is more than 5, so we take 1 here, so we get 0.4. Very simple. Here we have 3.57 decimal place, so here will be 3.6 because the 7 is more than 5. Here to 0.95, so it will be 1, right? So this very simple. You can pause the video and do the rest. Here's to 2 decimal places means when we count 2 decimal places, so this is the 0.12, so we are looking at this number. So we look at the one behind it, right? And we used to run that. So here we have 1.09, right? Because the number behind where we are running is more than 5, or more than 5, so we can run it like that, right? So here we have 2 decimal places, so we look at 1, 2, look at the 5 and the number behind it to run it. So we have 0.46, right? We have 12.12, so we are looking at this number 3, then the one behind it to run it. So since this one is 4 or less, we just run it to 12.23. As simple as that. You can pause the video and do the rest of it. Let's look at the next concept here. So the next concept we are going to talk about percentage, right? So a percentage is a part of 100, right? So if you have 25%, which means is 25 on 100, right? Very simple. If you have 50%, 50%, this is 50 over 100, right? Even if you have 125%, it is 125 on 100. 200%, it is 200 on 100. As simple as that. That's what we are going to talk about. So let's change this percentage. So if you have change it percentage to fraction, so 10% will be 10 on 100, and now when we change it we get 1 on 10, right? Very simple. So this is 1 on 10. 45%, which is 45 on 100. Now 5 will go here, 9, 5 will go here, 20, right? So we have 9 on 20, right? So you can pause the video and try to do the rest. If you have any question, put it under the comment section and I'll answer you. Now, changing fractions into percentage is very simple, right? So whenever we have fraction, want to change it to percentage, just multiply it by 100 and you get your answer. So 1 on 4 is times 100, right? So 4 will go here, 1, 4 will go here, 25. So it's 25%, right? You can also change this fraction into decimal and you use to multiply 100 and you get your answer. That can also be possible. So let's say you have 1 over 2, so it's times 100, which 1 will go 2 will go here, 1, 2 will go here, 50, right? So this is 50%. You can also change this one to 0.5 times 100 and you get your number to be 50%. Very simple, right? So we have some practical question here. So this is 50%, right? We have 2 over 5 times 100. 5 goes here, 1, 5 goes here, 20. So 2 times 20 is 40. So here is 40%, right? You can pause the video and try to do the rest. Very simple as that. Now, changing percentage into decimal is very simple. Let's say you have 25 over 100, right? We have 2 zeros, so you just have to, let's say so in this part of it, the point is going to be at the last point. So we are just going to shift it 2 times. So we get 0.25. So if you have 75 over 100 is 0.75, right? If you have 5%, means 0.05, right? Very simple. So here we have some right here. So this one is 0.45, 0.1, 0.25. You can pause the video and try to do the rest. Very simple as that. Now let's go to the last one right here. So with this one here, we are going to talk about ratio and proportion, right? So a ratio expresses the relationship of one quantity to another. So when solving dosage calculation, a ratio is composed of 2 numbers that are separated by a colon, like what we have here. 2 is to 4, 4 is to 16, and 1 is to 50, right? And proportion shows the relationship between 2 ratios that are equal, right? So we have 1 is to 1 is to 2 equivalent to 2 is to 4, right? So that's what. So the first example is read like 1 is to 2 as 2 is to 4, and you can see that these 2 ratios are equal, right? You can see that these 2 ratios are equal because when you reduce this one into the lowest term, you still get 1 is to 2 as is to 1 is to 2, right? It's very simple. 2 is to 8 as is to 5 is to 20. So when you reduce this one, you are gonna get the same thing, right? It's the same thing. So what we are gonna do right here is to solve some example right here. So if we have 3 is to 5 as is to 15 is to x, how are we gonna do it? For me, I'll just bring 3 here and bring the 5 down. All right, then divided by 15, or multiplication, okay, x, so that will be x, right? So this is the ratio and proportion form. So 15 multiplied by 5, so 5 divided by 3x, right? So we want to find x, so we divide 3, so we have this, then 15 goes here to be 3, goes here to be 5, so we have 25. So x is 25. So what I'm trying to say here is that whenever you have, like, let's say we have 3:2, then as is 2, 5:2x. Let's find x, right? So when you have something like this first one go as a numerator, right? So 3, and this one goes as a denominator as 2. Then with cross multiplication, this is not multiplication sign, this is a cross multiplication, right? Then 5 goes as a numerator, then x goes here as that. So the 2 here goes that, like that. It's like we are matching this one to this, then we are matching this one to this. That's what we are doing. Then we multiply in the like, and get the answer for the x, right? So 3 times x is equal to 2 times 5, right? Then we divide 3, then when you do it, you get your answer to be 10 on 3. Then you have to change it to mixed fraction as we did. Very simple as that. Very simple as that, right? So we have a lot of problems right here. You can solve that, and if you have any question, any concern, you can put it under the comment section and I'll attend to that. Thank you for watching this video. In our next video, we will talk about how to convert units